Hello, everyone. Welcome to Chemistry with Professor John. All right, we are continuing with alkyl halide substitutions and eliminations. Okay, this is the second part. All right. Well, last time we talked a little bit about SN2 reactions, that's substitutions, biomolecular substitutions. Now we're going to go into the unimolecular substitution, which is SN1, and then we'll go into the biomolecular elimination and unimolecular eliminations. All right, let's take a look at it. SN1, unimolecular, one step at a time. Okay, it might take 2 steps, it may take 3 steps. Okay, now if we have a bromide, that's the halide, it can be replaced by the solvent, alcohol, or whatever that's not strong, nucleophile. So the way to recognize this is to look for the nucleophile. If you don't see a strong nucleophile, then you know you're not dealing with SN2, okay? You're dealing with SN1. Strong one, I mean the negative one, like strong nucleophile would be OH minus, OCH3 minus, and they usually come with, not usually, they have to come with a positive ion like sodium plus, okay? So you will see sodium hydroxide, sodium methoxide, so on and so forth. CN minus, thing like that. Those are the popular one, okay? Now, or OCH2, CH3, okay? Those are the popular one. Now, for this one, you don't see those. You see weak nucleophile, like CH3OH, water. Okay, so basically they're also solvent. Okay, now those are neutral nucleophile and weak nucleophile. So that's how you recognize them, right? Now, the because there's a cation intermediate, okay, the tertiary will be the best one. Exactly the opposite with SN2. Secondary is next, and then primary probably never happens, okay? Now, for SN1, it's going to form the cation first. After the leaving group, X taken off, okay? Leaving group, X, it be halogen like Cl, Br, iodide, also OTOS or OTS. That's tosyl, okay? Those are the leaving group, meaning they taken off and then replaced by a nucleophile. Okay, in terms of solvent, SN1 is not picky. Any polar solvent like alcohol, water will work. Okay, now stereochemistry is really important. Remember the first step is going to form, the leaving group takes off, it's going to form the cation. The cation is planar, okay? Okay, so that means the incoming one, the nucleophile, that's the weak nucleophile, also the solvent. Okay, the weak nucleophile coming from the top or coming from the bottom, top or bottom. You see that? If coming from the top, you get the top one. So notice this S, you're taking out the bromine from the top and you put it in from the top. Therefore, you get a retention. Same stereochemistry. That's what it means. Now, if it coming from the bottom, because it's planar, it's coming from top or bottom. If it coming from the bottom, you get the inversions, meaning the other enantiomers, the R. So we got a mixture, 50% each, right? So we got two products. Remember the SN2 You only get one product. You start out with S, you get only R. Okay? Now, for SN1, okay, so SN2, for SN2, you start out with S, you get the R. For SN1, in this case, you start out with whatever. You always end up with S and R. Okay? So, regardless of whatever you start out with, you always get a mixture. That's the difference. Okay, sometimes that's a problem. More products doesn't mean it's better. Okay, we would just want one kind of products. Now, here's another situation. Because of the cation forming, there's a chance it rearrange. Okay, it change into a different cation. For example, this one, if we take the Br off, okay, notice that's a neutral. That's a weak electrophile. I mean, weak nucleophile. When it take off, we got a cation, and that's a secondary. Secondary cation is the cation that's bonded to two other carbon. Okay, secondary. It's not the best. It's good, but it's not the best. What happened is the hydrogen next, or the carbon next door, moved to it. There you go, leaving the carbon next door missing a hydrogen, so it become a positive, and that's a tertiary because it's bonded to three other carbon. That's a tertiary. That's better, more stable cation. Okay, so you got a secondary, which is decent. Okay, react with the weak nucleophile, which is the solvent, ethanol, weak nucleophile. Okay, all right, and then eliminate the hydrogen. Of course, that's eliminating hydrogen will be eliminated. So you got a product, tertiary, and you got a product that's secondary. Okay, so secondary is not bad, it's decent, but tertiary is better. So that's going to be a major product. All right. Now, when you got a primary, when the bromine takes off, automatically the methyl ship over. If there's no hydrogen, if there's three methyl, one of them is going to ship over and form a tertiary. The tertiary is always the best. Okay? Always. So that's the major product. All right. So that's SN1, everyone. SN1. Okay? Now, let's move on to eliminations. Now, SN1 is substitutions. The leaving group take off, nucleophile comes in. Now, that's not going to happen here. Eliminations is when the leaving group takes off, all right, and it's form a cation. So this is a tertiary, so it's going to form the cation. That's a tertiary. That's very good, right? Tertiary, very good. Okay, now instead of the incoming, okay, notice that usually there's a little bit of heat that will help with the eliminations. The incoming nucleophile doesn't come in. Instead, it wraps the hydrogens. There's two options here. One is the hydrogen A or the hydrogen B. Okay, if it wraps the hydrogen A, we got the products. Terminal alkene. Alkene on carbon number 1, right? Now, if it wraps the hydrogen B, we got the internal alkene, which is better. Okay, that's a more substituted alkene, so it's more stable. All right, so we got two products, but anyway, one is alkene number 1, one is alkene number 2. All right, so it's a mixture of the two, but of course the top one is the better product. It's more stable products. Now, eliminations also, of course, competed by the substitutions. So we got the elimination products. We also get the SN1 product. So that's E1 product. And okay, And then the bottom one is the SN1. Okay. All right. So that's possible. That get a mixture of two products. All right. So um, the last one will be eliminations bimolecular. Okay, bimolecular, and similar to SN2. Instead of leaving group takes off, the bromine you guys can see right here, bromine taken off. Instead of the strong nucleophile coming in replacing the bromine, instead of doing that, it's taking the hydrogen on the carbon next door, making a double bond. 2-3 step happen at the same time. In this case, 3 step. Bond breaking and bond forming happen at the same time. So we got an alkene. Pretty cool. All right. And so here's another example. We got an alkene. Notice the alkene number 1, which is called terminal alkene. It's only 19% in this case. That's not as stable. The internal starting carbon number 2 or higher, right? We got a more stable because that's alkene has surrounded by branches, surrounded by carbon, so it's more stable, stabilizing the double bond. So it's the major products, 81% versus 19. Okay. Instead of stereochemistry, notice that the leaving group, the base wrap the hydrogens, okay, and the leaving group, they have to be opposite, meaning anti-coplanar. Anti mean opposite, right? Remember the conformation stuff? Okay, so that way the base not in the way of the leaving group. That's all it is. Okay, so and that sometimes affect the product. So for example, this one right here, you got the bromine taken off, eliminating the hydrogens, and then form the double bond. So this is a trans, the way it's eliminated hydrogens, and it's always trying to stay away from the bromine. Now, if you turn it around a little bit, notice the difference. The bromine's in the back now, instead of bromine in the front. Okay, so notice the difference. You get the cis. The two phenol group get pushed to the same side. Okay, so it does affect the stereochemistry of the products. Depending where the bromine and the hydrogens are. Okay. All right. So here's a good summary of SN2, E2, SN1, E1. So you guys can take a look at the summary in terms of the reagent, the main substrate, and also the solvent, the nucleophile strands, and all that stuff. And it's good summary when you have a tertiary, when you have a primary, and when you have a secondary. What are the possibility, and that's very helpful to determine which kind of mechanisms. Sometimes it doesn't matter what mechanism, you end up with the same product anyway. But of course, it's good to know the step, what happened to them. Okay. All right, we got some additional problem for practice, and you guys can check it out. And also your homework discussion problem set. Check it out and let me know if you have any questions. All right. Well, thank you, everyone. And I hope you enjoyed the lecture and see you in the next one. Thank you.